Hello everyone, welcome back to SISYA Class YouTube channel. So I hope you have seen the last session in which we have discussed the different methods of separation. आज हम वहीं से कंटिन्यू करेंगे, आज हम कुछ और मेथड्स सीखेंगे. So I hope आपने वहाँ से related content देखा है, उससे related questions solve किए हैं, because we are going to follow up on that today. Okay, so let me introduce myself first. So my name is Nidhi Narwal and I have done my post graduation from IIT Bhubaneswar. I have over 6+ years of experience teaching a large number of students. So what are we going to discuss today, everyone? We are going to continue with our methods of separation part 2. We are going to take a quick recap of what we have covered in the last class, and then we are going to start with our today's session. Okay, so let's begin, everyone. Let's start with our session for today. So this is what we have covered in the last class. If you have followed that class, I hope you are able to understand what is hand picking method of separation of different components of the mixture. What do we mean by threshing, in which we beat the crop so that your grains, they separate out from the stalk. पर इसका disadvantage क्या है? That along with the grains you get the husk. You don't want husk, so you have to separate it further, है ना? तो उसके लिए हमने use किया था winnowing. By winnowing, you blow the wind, the lighter particles they flow away like your husk, and your heavier particles they fall down, and like that you can separate them based on difference in density. Then finally, we have seen what do we mean by sieving, in which you filter out the particles, you separate out the particles based on their size. So like your smaller particles, bigger particles, you can separate them with the help of sieving. So we have seen examples of that as well. Now what are we going to discuss today? Today we are going to understand about what do we mean by evaporation, what do we mean by sedimentation and decantation, and finally how can we separate out the different components of a mixture with the help of filtration. The simplest method that you all know about. We are going to understand what are the steps involved, what are the different types of components we need for that, what is the experimental setup. We are going to see that as well. Okay, so without further ado, let's start with our session. Let's understand about evaporation first. You already know about this process of evaporation. You have learned that in different states of matter or a journey through different states of water. You have learned that chapter. In that case, we have seen that how you can convert one state of water into another, that you can convert your liquid water into vapor. What was that process? Evaporation. So we are going to start the chapter, we are going to start the session with a small activity that you can do yourselves. Okay, so what are we trying to do? Let's see. We are going to take a small bowl of water, okay, nice, and we are going to fill it half with water. So you can do this kind of experiment, this kind of activity yourselves also at your home. It is so simple. So what we have taken a small bowl of water, you know, we have filled it up to half. Great. What are we going to do next? We are going to add salt into it. So basically what we need is salt water. So you have prepared a mixture of salt plus water. Okay, nice. We can do it ourselves. Yes, you can do it yourselves. And you are going to learn today how to separate these components. Okay, you can mix salt with water. You can make a solution. But how to separate that salt from water, we are concerned with that today. And we are going to learn it. Okay, so what we have done, we have added 2-3 teaspoons of salt into it, and we stir it so that the salt completely dissolves in water. We are not allowing it to settle down. We are allowing the complete dissolution of salt into water, right? And we are not adding much here. Only 2-3 teaspoons we have added in a half of bowl of water, and you can easily dissolve 2-3 teaspoons there, right? So now you have salt plus water solution. We have completely dissolved those 2-3 teaspoons of salt in the water we have taken, and now you have a complete solution before you. Now what is array? We are talking about different methods of separation, obviously. So we have to separate these components. What are we trying to separate? We are trying to separate this salt from water, obviously. Okay, let's see. So we have taken a small piece of black or dark colored thick paper, and we have spread a few drops of that salt solution onto it, right? What we have done, you have prepared the salt solution, correct? You have taken small amount of water, you have added salt into it. Okay, nice, we have done it. Now what next we are doing? We have taken a small, we don't have to take a large piece of paper or a large piece of cloth. A small piece of cloth is enough. We are going to add that salt water drop by drop there. Okay, so please see, we have taken a small piece of black or dark colored thick paper, and we have spread a few drops of the salt solution we have prepared on it. What are we trying to achieve? We are trying to see the process of evaporation. We are trying to separate out that salt from water. What happens when we add a few drops of that salt solution on this piece of paper? Let's find out, everyone. We are doing an activity that you can do yourselves, and we are trying to see the observations, what we can observe from here, which method we can employ in order to separate out salt from water. Okay, let's see. So we allow it to dry and then we observe it. So when it dries, the water will evaporate, we all agree. What will be left behind on that black paper? Why have we taken a dark colored paper, a black colored paper? Why not simple white sheet of paper? Because salt is also white in color. We are trying to see the separation. So if we have taken this dark colored paper, you can easily see the salt that would be present on that piece of paper after the water has evaporated. So that is the point of taking that dark colored sheet of paper. There is a point behind everything. We are not talking randomly that take any piece of paper. No, take a dark colored piece of paper so that you can easily see the salt particles which are left behind after evaporation of water. Okay, please see. You can feel the presence of salt by touching that piece of paper. So I hope you can see these patches. Not exactly it will come out in the form of this beautiful flower. That is up to you how you are spreading that salt solution onto your piece of paper. You may get this flower also if you are creative enough. But if you have just added the drops randomly, then also you will see some patches of salt are present on my piece of paper. Now, how can we understand this kind of observation? We have done evaporation, everyone. The water from your salt solution has evaporated. So what is left behind? Salt is left behind in small patches. So we have separated salt from water. Water evaporated, salt is left behind. Salt plus water solution, we have separated the components. Which process are we talking about, everyone? Evaporation. What happens in evaporation? Your liquid, it changes into vapor. This is what happens in evaporation, everyone. Your one component, it changes into only the state of matter changes, right? If liquid changes into vapor, we call that as evaporation. And this is what we have done. Salt is not evaporating. So we see the salt patches on the dark colored piece of paper. As simple as that. Okay? So these are the observation. Where has the water disappeared? Water has evaporated. So if you want to separate out from solid, from liquid, you can allow that liquid to evaporate, just like we have done here with water. Water evaporates and the solid that we have mixed with that water, it is left behind. So by the process of evaporation, you have separated a solid component from the liquid. As simple as that. Okay? And you can see the process of evaporation here also. You've added some liquid droplets here, right? So I hope you can observe how that liquid is evaporating. It is changing into vapors and the water disappears. What is left behind? Salt, everyone. If you have taken salt solution, what if we spill some amount of water on any surface? We are not talking about any salt solution. I'm just talking about pure liquid water, and we allow it to vaporize by itself. What will be left behind? Nothing. The water will turn into vapors and you will have a clear surface after evaporation. This is how we can convert the liquid into vapors. What is required? You can heat it. No need to do that as well. It will evaporate at room temperature. We are not trying to boil the liquid. We are just allowing it to spread over a large surface area so that it can convert into vapors easily. Okay. So done with the evaporation, everyone. This was the first method that we were talking about. So the water evaporated, it turned into vapors. As simple as that, and you are done with it. Okay. Now, in Ayurveda, how we use this process of evaporation in Ayurveda. So in Ayurveda, a traditional Indian health system, healers, they use certain parts of plants like roots, leaves, flowers, or even seeds as medicine. So how is evaporation coming into picture here? They first dry those roots, those leaves, those seeds so that the excess water evaporates, and then they turn them into medicine. So here also we are taking help of evaporation. We are trying to remove the excess water. We just dry it out in the sun. We don't have to do anything from our side. We don't have to heat it or anything. We just let it dry out in the sun so that excess water evaporates, and what is left behind? Dried part of roots, leaves, flowers, seeds, and then we can crush them and we can turn them into medicine. This is what is being done in Ayurveda. So this is a traditional Indian medicine. People were aware about the process of evaporation from such a long period of time. We are using it just now to separate out our liquid from the solid solution. Okay. Now, we see this is what they are doing. They are allowing the excess water to evaporate, vaporize. So what is left behind? The dried part of leaves, seeds, flowers, everything, roots that we want to prepare the medicine. Okay. So to prepare them, these plant parts are gently dried in the shade. Only the small part of it is what we need. So we allow them to dry. Just we are letting the excess water to evaporate. We don't want to destroy them. We don't want to burn them. So we just dry them in shade, and what is left after that? Your dried seeds, roots, flowers that you can use as medicine. As simple as that. Okay. Now, this lets the extra water evaporate, or what is left, that was important. The healing material, the medicine we were trying to prepare. So in Ayurveda also, we are using the process of evaporation to separate out our solid medicine, the healing material, from extra liquid that we don't want. So we have taken help of evaporation here also. This is what we are trying to understand here. Another method of separation that we have learned, and if you remember in the last class also, when we were talking about that dandy march, the formation of salt, we are actually talking about the process of evaporation. If you all remember, we have done this in last session also, yesterday as well, but there we were talking about formation of salt. Here we are talking about evaporation in terms of a method of separation. The principle remains the same, but we are seeing other applications of the exact same process, that how we can use it in our everyday life. Okay. Now, we do another activity. We take some salt in a beaker, right? You have taken some salt in a beaker, you have added water to it. What are we doing here? We are heating it. What are we trying to do? We are doing that same process of evaporation. Now we have taken a different setup, right? In the beginning, we have done just that, but there we were talking about how we can add that salt solution to a dark piece of paper, and we will see some patches of salt on that dark piece of paper. We are going to do just that now in a beaker. So in a beaker, you have added some salt and you are heating it. What will happen when you heat it? So you are turning your liquid into vapor. What else are you doing? What will be left behind in the beaker? Salt. So again, you have separated your water from the salt solution, And this is how you can do the separation. Again, we are doing the process of evaporation, but we will learn one more thing here, that how can we get back both water plus salt. If I evaporate, if I boil it, then water evaporates, it is lost. What is left behind? Salt. But I want that water also that I have taken here. I want that water also, liquid also, I want it back. So what should I do in that scenario? Do we have a process for that? Yes, we have a process for that. Let's find out. So we heat it and we let the water boil away. Is there a difference between evaporation and boiling? Yes, there is a difference. In evaporation, it is a surface phenomena. Only the surface particles, they are vaporizing. Okay, you are not heating it. They evaporate themselves. They themselves turn into vapors. It is a very slow process. It is a surface phenomena. Boiling, on the other hand, is the bulk phenomena. The particles from the bulk of the medium, they are also turning into vapors. It is comparatively fast because you are heating it, obviously, right? So boiling is a bulk phenomena. Particles from the bulk of the medium, from the bulk of the liquid, they are turning into vapors, right? In evaporation, only the surface particles were turning into vapors. There is a difference between boiling and evaporation. What process you can use in order to separate out your solid components from your liquid? Okay, we see. We allow the beaker to cool down. This will be left behind, everyone. The salt that you see here, it will be left behind in the beaker. Where is the liquid water now? The liquid water has evaporated. It has turned into vapors. It is no longer present in the beaker. We only have the salt in the beaker. So this is similar to evaporation. It is very similar to evaporation. You have once again turned your liquid into vapors, but now we are concerned that I want that water also. I don't want just the salt. If I am separating two components, I know I need these two components in the end also. So how to get back water also? Along with evaporation, if you do condensation, then you can get back water as well as your salt. Please see. So you can feel the presence of salt in the beaker by touching the salt with your fingers, and you can clearly see it also. If you have added a large quantity of salt, you can clearly see it. If you have added a very small quantity of salt, maybe you are not able to see it clearly, but if you touch the bottom of the beaker, you will have small salt particles present at the bottom. If you taken a very large amount of salt in very little quantity of water, a large amount of salt will be present behind also. It all depends upon how much quantity of salt you have taken in your beaker. Okay, everyone? So we can feel the presence of salt at the bottom of the container just by feeling it with our hands. Great. So is there any method through which we can get both water as well as salt back? Yes, there is a method, and this one is important. If you do evaporation along with condensation, you can get back both of your components. Let me show you how. See, evaporation is conversion of liquid into vapor. Then what is condensation? The reverse process of evaporation. If you turn back your vapors into liquid. This is what we mean by condensation. So you have separated out your salt from the water by evaporation. Now if you collect that water, you can turn it back into liquid. So evaporation plus condensation can give us both back, right? The salt also and the liquid water also, right? So what we can do, we are going to heat that salt solution in this kettle. So all the liquid that is turning into vapors, we are going to collect it and we will allow it to condense into liquid water once again. So you have separated salt and water and you have collected the water back. The salt is still here. So you have both of your components back. We are not leaving anything behind. We are getting both our components back. Okay, so this is what we can do. All right, everyone. Now, can you answer this question? After heating a salt solution in a beaker and when you let it cool, what do you observe remains in the beaker? You have taken salt solution, you heat it, so your liquid will turn into vapor. So what will be left behind? What type of component we have taken in the beginning? Salt. Obviously, salt will be left behind. Water vapor? No, it too will evaporate. It too will be lost. Salt? Yes. Sand? We have not taken sand. Oil is not part of our mixture. So obviously what we will get back? We will get our salt back in the container itself. Okay? Hello Roshan. Okay everyone. So we have done evaporation and condensation in order to get back both the components, and if we are just doing evaporation, we will get the salt back and the water will turn into vapors. It will be completely lost to us. Okay, so we are done with first process today, evaporation, by which we can separate out the different components of the mixture. Let's continue. Let's learn about other methods of separation. So now we are going to start with another activity, another observation that you tell me how to separate the components from there. Okay, so let's begin. So we are visiting our grandpa's garden. Okay, do you see different types of vegetables are planted here? We see a lot of flowers. So we are visiting our grandpa's garden. What do we observe? We are trying to eat vegetables from there. Okay, what type of vegetables we like to eat? Let's say we want carrots. Okay, so the carrots are there. We want those carrots. How are we going to eat those carrots? We have to first wash them, right? They would be very muddy. They would have a lot of unwanted material on them that we don't like to eat. So obviously we will wash them first. So the activity is based on that only. We are going to learn about another method of separation today. Let's begin. So every Saturday morning, Arya and Ryan, they help their mom wash carrots fresh from grandpa's garden. So grandpa's garden has these carrots. We like to eat carrots. So there are two kids just like you. They go there to the garden and they pick out those carrots and they want to eat them. So how will they eat them? They have to wash them first. So their mom helps them to wash the carrots. Now what do they observe? They have taken a clean bowl and they add their carrots to that clean bowl. And they want to eat it, so obviously they will wash them thoroughly. Now what do they observe? When they take the carrots out, all the mud, all the unwanted material, it is left behind in the bowl along with water. So how can we separate out that sand, muddy water? If you want the sand separated from water, can we do that? Can we separate them? Yes, we can. We are going to learn about another method of separation now. Okay? My name is Nidhi Rohit. Okay, so we get this muddy water. In the end, we don't want that muddy water. We want to separate out the mud, the sand from water. Can we do this kind of separation also? Okay, salty water we understand. We just evaporated it. Can we do the same thing here? No. There is another very simple method by which you can separate out your sand from water. Let's see how we can do that. Okay. So this was their observation. One day, after they have rinsed the carrots, what do they observe? That the big bowl of water is now muddy, like chocolate milk. It is not chocolate milk, everyone. This is muddy water. I hope you can observe there is sand mixed with water. And based on how much amount of sand you have in that water, it will be very sticky also. If you have lesser amount of sand, it will not be that much sticky. But one thing you will observe it is not going to mix with water. What is the difference between that salt plus water solution that we were talking about earlier and the sand plus water mixture that we see here? That salt dissolves in water. Sand is not soluble in water, everyone. Sand is insoluble in water. Is this information helpful to us? It is very helpful to us. Based on that, we will decide what type of method we have to use in order to separate out sand from water. How is the insolubility of sand going to help us? We are now going to learn about sedimentation and decantation. What is sedimentation? You have this muddy water, no? You have this mixture of sand plus water. You allow it to settle down. Okay, don't do anything, just leave it undisturbed. What will you notice? That the entire mud, the sand that is part of your water, it has settled down, and above it you will see clear water. All the unwanted particles, sand particles, mud particles, they are going to settle down at the bottom of your container. And what would be left behind? Clear water. So what should we do next? How can we separate out that clear water from the muddy solution? Let's find out. Let's learn about the process of sedimentation. So they waited for a few minutes, and slowly all the tiny specks of soil, mud, sand, whatever you want to call it, and carrot bits, they sank to the bottom of the container. Why are they sinking to the bottom of the container? Because they are heavier. They have high density. They have high mass. That is why they are settling at the bottom. Water is lighter. Water is present as a layer above the sand particles, the bits of carrots you have taken. Okay, so this was the situation in the beginning. This was your muddy water. Now you have left it undisturbed for some time. You have not done anything. You are not going to do anything with the beaker. You will just leave it as it is. So you will notice now all the sand, all the unwanted particles, the heavier particles, they will settle down at the bottom of the container. So you can clearly see the separation of layers now. So this is what we mean by sedimentation, that your heavier particles, they settle down. They are present at the bottom of your beaker. Now the process of separation becomes easier for us. Let's see what we have to do next. Yes, Roshan, we have a IIT program here at SISYA Class. You can download our app and you can know more about us. We are running a JEE Foundation series also, right, on our app itself. So you can learn more about it. Very good evening, Munna. Okay, Roshan? Alright, so this is what we have done. We have separated out the mud from the water. It has settled down. Now our next aim is to separate it completely. We want the mud out of the water. What should we do then? Very simple. Please see. The process of settling down of heavier, insoluble component, that is your sand, that is your soil or your mud, at the bottom of the liquid, this is what we mean by sedimentation. As you can see, this is heavier and insoluble. So it has settled at the bottom. Okay, so the process of this settlement of heavier insoluble substances at the bottom of your container, this is what we call as sedimentation, everyone. Is this how we separate them? No, we are not done with it, right? You have just seen the separation of two layers. Now we have to separate them completely. What should we do for that? We are going to do decantation. What is decantation? Very slowly you will tilt the beaker so that the bottom heavier particles, they are left at the bottom of your container, and very slowly and gradually you will decant the clear liquid from that container. So your liquid, you will take it out in a separate container, and what will be left behind, everyone? Just the sand or soil or mud. This will be present at the bottom of your container as it is. No one is going to do anything with it. Okay, please see. you are going to pour that liquid at the top into another container, and can you see all the mud is left behind at the bottom of the original container. We are not going to do anything with it. This is what we mean by sedimentation, decantation. That is all you have to do. Okay, so carefully we have to tilt the bowl or the beaker wherever you have that muddy water, and you will allow it to move to another container. Sand, mud, everything, you will not disturb it. You have to be very careful while decanting it, and you can separate out the two components. This is what we have done, as simple as that. This is what we mean by sedimentation and decantation. Okay, let's see the definition now. I hope you understand the process. You must have done it yourselves also. So, when the liquid is removed by tilting the vessel, the process is called decantation. So if you do these two processes together, sedimentation and decantation, you can separate out your mud from the water, from the soil. As simple as that. Okay. So sedimentation and decantation to your rescue if you want to separate out mud or soil from water. This is what you are doing. Okay. So when the liquid is removed by tilting the vessel, this process is called decantation. This is what we have done just now, and together we can use sedimentation, decantation, we use it together, right? First we allow the heavier particles to settle down, and then only we will tilt it so that all the clear liquid is removed from the container. Okay. So now whatever liquid was left behind, we can use it to water our plants, we can use it to wash different surfaces. It will have plenty of uses because it is not muddy anymore. Now you have that water with you, comparatively cleaner, right? So their mom used it to water indoor plants, and the muddy layer went back to grandpa's compost pile. We will not waste the sand also, we will not waste the soil also. We are going to use it to plant more vegetables, carrots, whatever you want to, right? So this is what we have learned today. Do we have any other examples of the sedimentation and decantation that we have just now seen? We have other examples also. Please see. See another example. See the entire process altogether. Okay. So first we have the muddy water, right? We allowed it to settle down. So the mud settles down. Okay. Awesome. Then this is what we mean by sedimentation. Now we will decant it to a separate container. So only the clearer liquid is removed and your sand is left behind. Your soil is left behind. Please observe. And please notice one more thing. In the end, we are using a strainer also. What was the need of that strainer? Let's find out. Okay, it also has some use. Hai na? Let's see. So we have done the sedimentation, we have done the decantation. See some more examples, then we will come to that strainer wala part. We will learn about another method, filtration. Okay, but see another example. This is also one thing that we do in our home, na? We wash the rice, we remove the unwanted particles, right? So what we do, we will wash that rice and then we will decant the container. So your rice is left back in the container and all your unwanted particles, they will flow away with the water. So there also you are basically doing sedimentation, decantation, everyone. Here, the thing that settles down, that is rice. We need that. We don't want that water that has unwanted particles, so we allow it to flow away, right? So you are using the same process here also, decantation and sedimentation, in order to remove the two components which are not soluble in each other. Okay. Now, can you answer this question? Why is decantation not suitable for separating milk and water? Can you separate milk from water with the help of decantation? Can you see them separating into two layers? How will you answer that question? Please see the options. Both have similar densities and mix completely. Milk is lighter than water. Water evaporates too quickly. Milk solidifies on standing. Can you see milk and water separating into two layers? If you could see that, then no one would mix milk with water, right? You can easily cross-verify it now. If it settles or separates out into two layers, that does not happen. Why? Because they mix completely. Milk and water, they mix completely. You can see the different layers. Obviously, you can't use decantation in that scenario. Why are we using decantation in the previous case? Because there you can clearly see that your sand has settled at the bottom and your water is present as a layer above it. So you can see the separation of two layers. Obviously, you can use decantation as a process there. You can do that here. Okay. Now, so option 1 is the correct answer. See another question. You have done this just now. I hope you can answer it. A teacher evaporates water from the salty water and collects the salt left behind, but the water is lost. Which method can we use so that we get salt and water both? We can collect the salt, no issues. But how to collect that water? You have learned that today. You can do evaporation, condensation both. Let's see the options. Can we do filtration? How will the filtration work here? Salt is completely soluble in water. So if you filter it, salt plus water, both will be filtered out. You can't separate them by filtration. Can we do sedimentation and decantation? Again, sedimentation and decantation is used when you have two insoluble components. In this case, salt completely dissolves in water. So this will also not work. Simple distillation, this will help us. In simple distillation, we will do evaporation and condensation both. By evaporation, we will turn the liquid water into vapors and then we will condense the vapors to get back our liquid and your salt will be left behind. So simple distillation can help us, not magnetization, as none of the components that we are taking in the mixture are going to be attracted to a magnet. You can use magnetization when one of the component at least gets attracted to the magnet. So you can separate them out by that process. Here it will not work. Okay. Now, what about this one? A muddy water sample was left undisturbed. You are not doing anything. After some time, clear water was poured into another container and the rest was passed through a filter. What sequence of methods is this? First, you have allowed the mud to settle down, sedimentation. Then you have removed the clear water that you see above, decantation. You still see some of unwanted particles are present in my clear water. So you have filtered it out also. Remember, we have used that strainer that we will learn about now also. So you have done filtration also. So what is the sequence of steps, everyone? First, we have allowed the sand or the soil to settle down, sedimentation. Then we have decanted the excess liquid, decantation, clear liquid. We still see some of the unwanted particles there. We have used a filter paper to remove those unwanted particles also, filtration. So sedimentation, decantation, and finally filtration. Okay. Now, which of the following mixtures cannot be separated using decantation? Such mixtures which are soluble in each other, you cannot separate it out with the help of decantation. For that, you need insoluble components. In this case, we have soluble components, as you can see here. This separates out into two layers. This also, this also. This salt plus water, it completely dissolves into one another. It will not separate out into two layers. You cannot use decantation as a process in order to separate them. Okay. Now, we see which property of particles is mainly responsible for sedimentation. That they are heavy, they have higher mass, heavier density. That is why they settle down, and your water, a clear liquid, is present above it. Size of the particles, density of the particles, shape or temperature. heavier particles, they settle down. This was the process that we are using. Okay, now let's talk about that straining wala example that we are seeing. That decantation may sometimes not give you a complete clear solution in the end. Right, we have allowed the mixture to settle down. We have removed the clear water, but sometimes that clear water also contains some of the sand particles. So what should we do here? How can we separate them? What type of process we can use here? So we are going to talk about filtration now. Let's see what is it. Okay, so the decantation does not completely separate. If you talk about this also, this is also an example of sedimentation and decantation. The tea leaves are present at the bottom. We are just taking the tea. We are not going to drink the leaves, no. So you are just separating out the tea from the leaves. But sometimes what do we see? You are very careful. Then also some of the leaves, they come into the tea. So what should we do here? How can we separate out the tea leaves from the tea? We want to drink tea, we don't want the leaves. So we have to use another method for that. What should we do now? We have to filter it. What should we do for that? You can use a strainer now. You use that in your homes now. That strainer that you are seeing in that example. What is the purpose of using the strainer? You will pass that tea along with the leaves through that strainer. Leaves being bigger particles, they will be left behind on the strainer, and only your tea passes through it. So you will have clear solution there. You can drink the tea now. So simple decantation may not have worked. So we have added one extra step, filtration. That similar question that we have answered just now. Okay, please see. We are going to pour the tea through the strainer. So all the extra tea is left on the strainer. What do we get? Clear liquid. Right? So we are taking the help of the strainer in order to separate out the tea leaves from the tea. So decantation, sedimentation, okay, we tried that. But decantation is also not giving us the clear product in the end. So we will take help of strainer in this situation. Can we use the strainer in order to separate out the mud from water? Will the strainer work in that scenario? Let's find out. So this process of separating tea leaves from the tea, this is what we mean by filtration. Here we are using a different type of setup. We are not using a strainer. If you notice, we have taken a filter paper. What is the method that we are talking about here? What are the steps involved? Let's find out, right? So this method we are talking about next. We have learned so far what is evaporation, how we can do evaporation, condensation, both in distillation to separate out the components. Then we have learned about sedimentation as well as decantation. Now finally we are at filtration, the last method by which we can separate out the different components of the mixture, everyone. Please see. So can we use a tree strainer to filter the muddy water? No. Why not? Because the mud has very small particles. Those the muddy water particles will pass straight through the strainer. So we will once again get muddy water in the container. So what was the point of using a strainer? A strainer has bigger holes. So your mud also passes through it. You need something else here. The strainer will not work. So what do we need? We have to take help of filter paper. Let's see what is it. Or you may take some cloth also. Cloth can separate out the mud from your water. That can work. Not the simple tea strainer that you have seen just now. Okay, PC. A tea strainer is not suitable for filtering out the muddy water. Why? Because the mud particles are small enough that they will pass through your strainer. So you need bigger particles so that they are left behind. If you have taken a strainer which has big holes in it, then your mud along with water will pass through it. There is no point of using a tea strainer in that scenario. Okay. So what are we going to do? We are going to take help of filtration. What are we using here? Can you see this filter paper? And we are adding our mixture on the top of this filter paper. So your unwanted materials is left behind on the filter paper and only your clear liquid is present below. So your clear liquid is obtained below and your mud, unwanted particles, they are left behind on the filter paper. This is the process we are talking about now, everyone. We are talking about filtration. Please see. So what is filtration, everyone? Let's find out what are the steps involved, what type of components we use here, what are the requirements. Let's find out. So first of all, we need a funnel and it is lined with a filter paper and placed in a beaker or flask wherever you want to collect the clear liquid. So this is your filter paper. You are going to place it in a funnel that you have seen just now, and the funnel you will place inside a beaker, a flask, wherever you want to collect the clear liquid. Okay, we have the filter paper and you will fold it in the shape of the funnel so that we don't waste any liquid, right? We want the entire clear liquid in our flask or container or beaker. So we will line the funnel with this filter paper. We will make it in the shape of the funnel. Okay, what should we do next? A mixture containing the liquid and the undissolved solid is now poured through the filter funnel. So you have lined your funnel with the filter paper and you are pouring your mixture over that filter paper. What will you see here? All the unwanted material, it is collected on the filter paper. And what is left behind? You will get your clear liquid at the bottom of your container. So you have separated them out. Yes, with the help of filter paper. Correct. What is the process called? Filtration, everyone. So mixture containing the liquid and your undissolved solid is passed through the funnel along with the filter paper. So your filter paper has small holes that allows only your liquid to pass through, but your unwanted material is left behind on the filter paper itself. And that's how you can separate it. So your sand is left behind. Yes. Your water passes through. Yes. So you have separated water from sand. Yes. Okay. What else we can do? The solid particles remain on the surface of the filter paper, as you can see here, and the liquid drips through into the flask. The liquid drips through and your filter paper will contain those sand particles that you don't want, right? Can we use something else? If we don't have the filter paper, can we take help of something else? Yes, you can take help of cloth material also. Those fibers that we have in our clothes, they also have very small holes in them. So they will allow the liquid to pass through and your sand, your unwanted material, it will be left behind on that cloth. So you can use cloth also. Please see. Try to filter the muddy water through a piece of cloth also. You can achieve that. Okay, so your cloth, the fibers have small holes that allow your liquid to pass through and your mud, soil, it is left behind. Okay, so try to filter the muddy water through a piece of cloth and now observe the difference. You will still get clear solution. You can still remove your mud or sand from your water. And if the water still looks muddy, we can remove the impurity by pouring through the filter that has even tinier holes. So you can try it with a cloth if you don't have a filter paper, but if you want a completely clear solution, obviously you have to take the help of filter paper because it will have the tiniest holes. That is the purpose of taking the filter paper, everyone. So what we have learned today, filtration, sedimentation, decantation and evaporation, different ways by which we can separate out the components of the mixture, everyone. Right? So can you answer these questions? A mixture of salt, sand and water is given. Which of the following is the correct sequence of methods to separate all three? You can do filtration, then evaporation, then sedimentation, or you can do sedimentation, then you can filter it out, and then you can do decantation or filtration, after that evaporation, sedimentation, decantation, and finally evaporation. See, first of all, try to understand salt is soluble in water and sand is insoluble. Okay, so if you filter it out, only your sand will be left behind, your water along with salt will be present in your container below. Then you can evaporate it. But if you want all the components with you, है ना? If you want all the components with you, this is the method you will follow. है ना? First, you will filter out the sand because it will have bigger particles. It is not soluble. है ना? What will be left behind? Water along with salt. Then you can do the evaporation. That is how you can separate all the three components all together based on different methods that we have learned today. You can follow this method. Okay, see the next one. A solution of sugar is dissolved in water. It cannot be separated by filtration. Why? Because sugar, like salt, is soluble in water, everyone. Sugar is heavier than water. Sugar particles are too small to be trapped by filter paper. Filter paper dissolves in water. Sugar reacts with water during filtration. Sugar particles are too small to be trapped by filter paper. It passes through. So you cannot separate sugar from water by filtration. You have to use evaporation for that, just like you have done with salt and water solution. So this filtration will not work here. Filtration will only work if you want to separate some component that has a bigger size, that will not pass through the holes, pores of your filter paper. Sugar passes through because it is small enough. Okay. So this is what we have learned today, everyone. We have learned about the process of evaporation, liquid turning into vapor. Then we have seen sedimentation, in which you allow your bigger, heavier particles to settle down at the bottom of the container, and then you can decant the clear liquid. You still have some impurities left. You can filter them out. So you have learned the process of filtration also. So these are the three methods that we have learned in order to separate different components of the mixture. Correct, everyone? Now, if you want to learn more about us, you can scan this code. You can download our app. Everyone who is interested to learn much more amazing content, you can scan this code and download our app. And if you want to see this content on YouTube, you can subscribe to our channel. So next, please tune in at 5 p.m. So you will have a maths class today, just like yesterday, and you will learn something new there also. So please like, share, and subscribe this channel to know more such amazing content. That is all from my side. Thank you so much for joining the session. Have a very great day. Bye, everyone.